Welcome back to our Python programming from beginners to programmers. In this video segment, we want to touch on the last topic on data analytics. We have gone through a lot on data analytics using Python's powerful libraries, NumPy and Pandas. Specifically, Pandas provided us with two new object types, namely the primary object data frame, the two-dimensional table, and the accessory data type series, which I was saying that you should think of it like a snake of consecutive cells that stores the data. So we've learned a lot about how to slice and dice by the columns, by the rows, by column values, by row labels, by data content, to be able to extract out cells systematically based on mathematical or logical expressions, to be able to derive subsets of cells and to assemble from smaller data frames into huge, gigantic, large data frame. We are also able to now very easily perform translation of the data values and to also programmatically uh, and automatically transform the data values from one form to another, from one data type to another. And we are able to also perform content filtering. So instead of just going through the positions of the table, sometimes it's not really what we want. We want to extract out significant data, right, by their content. We also learn things like apply and apply map and map in order to easily modify, inspect, or else process interesting cells where what is interesting is up to us to define, right? So it's really powerful, flexible, easily done, and very clear in the logic of what we want to do with the data frame. And we learn how to filter off noise, and we learn about different kinds of problems, data problems, problem sources from null, then from noise, from wrong data types, and all these are to adhere to the garbage in, garbage out principle. We don't want to feed our processing pipeline with garbage, right? And we can do a lot. And in the recent video segments, we also learn how to perform statistical analysis very easily using powerful features like group by and pivot table. Now, in this final video segments, I like to touch on permanent storage, right? So we have done a lot about how to operate on the data frames and series once the data frame is inside the memory. So all along, I've been creating examples using typed in data values, or else it's generated by random numbers. But of course, while that is great for illustration, that is really not what we are going to do in real life, because real life data will most likely be stored somewhere in text file, in Excel, on web pages, and all that. So today, in this video segment, I'm going to bring us to the 4 important text file types that we can operate on using pandas functions. Very straightforward manner and really no nonsense. It's very simple, right? So the moment we want to read in data from the hard disk, which is stored outside the memory, we simply says pandas read it in, right? So we just read in the data type. And if we have completed our processing in pandas and we need to sort of dump out the processed data frame, we just say to the file. That's it. All right, so by following consistent naming of the functions, it makes it really simple not to make us memorize, all the different ways of spelling the function name. So it's very simple and straightforward. After seeing a few examples, I'm sure you can just catch on. So our discussion today will talk about 4 different file types, right? The whole idea is to read and write data. Now, why do we need to do that? I thought we already have that, right? But data, for it to be stored permanently, we need to preserve it into the hard disk, the hard drive, all right? Because when you power down the system or you exit Python, all the memory is gone. And so when you say type the df, the next time you run Python again, the df3, df6, and all the examples that I've been showing you will no longer be there. And you will have to retype it in or else run the program again. But that's a bit very rigid, right? And so we need to be able to process incoming files. Now, in real life, we might be downloading the file from the internet. We might be just copy and pasting from the company's server file. We might be receiving a thumb drive from our, colleagues or superiors or customers, a text file having some sort of a column-based layout. We may be getting a CSV file of a sales order. We may be getting a excel.xlsx file of our weekly revenue. So all these are data that are very prevalent in our daily lives, and we need pandas to be able to process them, right? So this is what is meant by reading data from these sources. So if you receive next time a text file, Excel file, CSV file, HTML file, don't worry, we can handle that, all right? And for each of these 4 file types, text file, CSV file, Excel file, and HTML file, we want to learn how to read when we are given one in the file, in the USB thumb drive, from email attachments, and to be able to write, to generate it from our processed data frame so that we can send it out as text, post it as HTML, upload to the server because the server system requires CSV file format, or else send it as .xlsx Excel file to our customer, our suppliers, and so on. Right. So these 4 very, very important data types, and here's how to operate on them. Now, so in this classroom setup where I try to use a very controlled static image with colorful paintings here to illustrate the effects of the commands, all right? And of course, in the next video, we will definitely try it out in actual computational background. So here, we will just create a data frame. All right, and I hope by now it is no surprise that we have a row called Chris 26.5, and all these could be income, could be measured temperature, could be whatever it is, right? So I just created that. And we have 3 records of 3 people, and that's quite common, right? I've been saying this about membership database. So each member is a list here, which is a row in the pandas data frame. And we have 3 members, and each member provides 4 pieces of data: the name, some measurements, and yes, no, 1, 0. So we have these information. So then we call these columns the names, name, age, credit, drives. So by now, this creation of the data frame method is, I hope, very familiar to all of you. And then out comes this data frame. Right? So remember now, we are trying to write, we are trying to generate a text file. So all we need to do is to create a data frame. And when you need to write it out, you are supposed to be saying which data frame, right? That's why you will be saying this particular data frame, this df here, okay? So whatever df you want to write. If it's df9, you say df9. So df, put a dot to string. Okay, you just say to string. We will be able to then output to the text. Okay, to string, and then it will be output to a text. Now, this is nice because it is giving us a piece of text still in memory. Still in memory. It is not out there in the file yet. But as we learned in earlier videos, it's quite easy. Just open up a text file, all right, and then just fs.write out the text, and that's done. So once this with statement is complete, at this point, we definitely have the text file out there. All right. So let's just look at this part, which is just to touch up on the data. For the name, we want to make sure that it is stored as string. And this is important because in case some of the values are not exactly string, then this will ensure that it is definitely string. So age as well, we want to make sure it is rounded to integer. All right, I of course I purposely put in some decimal places. In real life, we don't know. Uh, we don't really try to corrupt our data, but you never know when you download the data, right? The person typing it in might not have been so careful with all the entries. When you download, someone might have opened it and then closed it. So from integer, it becomes floating point because of file conversion and whatnot. We never know. So don't try to be too sure, and it's always good to ensure that the type is correct, right? The last assurance here before we write it out. Then we ensure that the third field is a float and final field is a boolean. A kind of example we have seen earlier on, just to give it a bit of variety. So when we print it out, we should be seeing this stored in the memory. All right. And just check the types again, and indeed it is correctly stored in the type that we intend. And then to save it, that means to write out to the hard disk, all we need to do is to first convert it to string, right? And we say to string index equals to false. This I always use, although it's not mandatory, because we don't want this 0, 1, 2 to be stored as an additional column. Now, pandas is very careful about preserving the integrity. Inside the memory, we do have this index here, right? Now, here, as we look at it, it's like, not really, we don't really want it. But remember, the way data frame is set up, it's always having that index. So whether it is significant to our application or not, it will be there. And if it's not significant, we just leave it. It's 0, 1, 2, right? So in such cases where the 0, 1, 2 is there, we don't care, we don't mind, but we don't really want it to be stored in the disk, because when we do that and we mail it out as attachment or we include it in our email, um, our recipient might be confused. What is this new column here? I thought we were talking about name, age, credit, and drives. Yeah. So, your colleagues or your customers, suppliers who are not familiar with pandas might not understand it. And even if you're familiar with pandas, it's quite a eyesore, isn't it? So whenever it's not required, we will not have it. But of course, sometimes we do internally make use of the index, right? So in that case, you do want to store it and then want to retrieve it wholesale.